All right. Thank you very much. This is a talk that I'm giving about a class that I'm teaching right now at NYU, where I have a group of about 10 students who are going through and trying to take their first steps to join this community by creating a project to secure some parts of the software supply chain. And I have a QR code here that links to these slides. I will also have the same QR code at the very end of my slides at the conclusion. So if you miss it here, you don't have to worry. It's going to come up in about 10 to 15 minutes. Okay, so as I said, I'm teaching this seminar class at New York University. There are 10 different students who are doing projects. I have one that the course assistant for the class is actually doing that I'm guiding, that he's like a week or so ahead of the students and showing them what this is like. There's 8 master students and 1 PhD student. And for the first 5 or 6 weeks of the class, I had guest speakers come in from the community and give talks on different technologies. So they presented a wide variety of the different things that you probably all know about and are aware of, so that the students have just a general background about what is happening in the software supply chain space. And the goal for the students were to do something small, to do something that people could actually adopt and use that would somehow improve software supply chain security. And you know, really what we wanted them to do is to be able to build a prototype, test it with real people, actually try to build a community and expand. And they could either create a brand new project of their own, or they could try to contribute to some existing project and add on to it. So I'm going to be talking about a few different aspects here. So one thing I'm going to drill down into a little bit is to where the students have gotten and maybe why they are where they are in this process. I'm also going to talk a bit about whether people tended to pick new projects or work in existing ones. And I am going to be ignoring the PhD student's effort in this, because this is a PhD student of mine who's been working on a project that's been going on for 14 years. And so this is a little bit of an outlier to the rest of the projects here that all started this semester. Okay, so to give you an idea, I'm going to go through 3 student projects in just a really high level, so you have some idea of what these look like. The first one is called the License Inconsistency Checker. And the basic idea here is that oftentimes when you go to a repository, you'll find things like, for instance, a documentation repository that has a GPL license or an Apache 2 license on it. Or you'll find things like software that has like a Creative Commons license or other things like this. So what happens is that in many cases you have licenses that don't actually match the type of the thing that they're supposed to protect. And Mike Dolan and his whole group can give you a much more detailed and informative spiel about why this is a bad thing. But in essence, if you're not protecting code with code licenses, documentation with documentation licenses, spec with spec licenses and things, you're actually leaving quite a lot of daylight for bad actors to do things that you're trying to prevent by having your license in place. So this student made a tool that actually goes through and tries to look at the licenses in the files that exist in your repo, and then warn you of situations where the license and the types of files are inconsistent. And here's their information. Once again, I'm going to have a QR code at the end here that is going to link to these slides that has all the student presentations, much longer versions of these than I'm going to go through. Another project that a different student worked on was dealing with dependency resolution predictability. And there's this kind of interesting thing that many people are not aware of, but if you use dependency resolution, if you ask a system to tell you what packages to install, many cases, many package managers use something called a SAT solver underneath. And if they use a SAT solver, then what happens very commonly is you can have situations where the SAT solver will make seemingly randomly different decisions about what packages to install in different environments. So that means that your dev environment, your test environment, and your prod environment might all be using different versions of packages. And they all might be correct. They all might meet the sort of requirements that exist, but I think that we can all maybe agree that this could be a scary thing, that the very first time that this combination of versions of packages has ever been tested with is in your production environment, not your test or dev. And so what this student has done is he's taken a look at this and looked at an older algorithm called backtracking dependency resolution, which is a much more understandable way of doing dependency resolution, where it effectively tries from top to bottom to resolve dependencies in the best way possible. And his approach to try to get this solved in practice, unlike the first approach, which was writing a tool that he hopes people use, is he's actually created a blog post about this and provided a bunch of evidence of real packages and real dependencies in real situations where this occurs. And then, has put his code and stuff up and is reaching out to groups inside the OpenSSF and others to try to raise awareness that this is a problem that people should know about. The final one that I'm going to feature rather quickly here is called Temper. And this is all about compiler hardening for C and C++ programs. And the basic problem here is we're actually, I think, going to see in the next talk here, so I'm kind of stealing their thunder, so I apologize in advance, is that there's a whole bunch of problems, and if we just use the correct compiler flags in many cases, that would fix a lot of these problems, is just really simply, quickly said. And so there's a guide about how to do this and what to do, and this is evolving advice, but is getting better over time. And so the solution here is I've had a student who's come and actually participated in some OpenSSF meetings and gotten some really nice feedback from some folks, including those in the room like David Wheeler here, thank you very much, who have guided him to help to make a better tool that can help to automatically do compiler hardening for you and make the process of doing this, change it from a manual one to a more automated one. And yeah, there's, once again, this information, these slides are all available. So I'm not going to go through these, but there's a whole bunch of other projects that the students worked on that all just try to tackle some very, very small problem and make it better. So I said before that we're going to have a few questions we're going to try to answer to try to see how new projects get started and what maybe is happening with projects at the early stages of their evolution. And so where are the projects at? Well, fundamentally, all of the projects that the students have worked on have a decent prototype together for the most part. But many of the student groups are really hesitant about actually reaching out to people and are kind of struggling with this part. And so I've started to kind of coerce them to go to OpenSSF meetings and just like drop in on calls and be around, because like one view they have is I build this thing and then like I zoom in for exactly one call, try to monopolize the call to pitch my thing, everybody will love it, and then I disappear off in the sunset. And that's just not how these communities work. So you'll start to see, I think, a lot more of these students kind of hanging out and trying to understand the communities and try to slowly reach out and do a gradual process. And I'm also working on strategies to try to get these projects in front of more people, things like this talk, for instance. So you're now all going to be aware that these things are happening, and there's going to be these students out there. So another question is, would people want to create a new project or work on an existing project? And essentially all the projects are new in this case. And I think that this might be biased because when they were first getting started, I really emphasized to the students that not to pick an overly big, ambitious thing. Don't try to reinvent like some massive part of the ecosystem or do some huge thing, but to really focus on some tiny problem that they saw. And half of the students came up with the idea themselves. There were some interesting ones like, one of the students went to download a package and the name of the package said it was targeted for one type of architecture, but was actually targeted for a different architecture, so it didn't work on her system. And then she just went and said, oh, what if I just check all things that have names and try to figure out what architecture they're from and see if I find anything else that's mislabeled. So that's like an example of kind of a cool project that a student came up with. where a lot of times it's born out of some frustration or problem that they noticed when doing things themselves. And I will say that it was actually quite hard for people to really choose an appropriately scoped real problem. I think there were problems in both directions where students wanted to choose things that weren't really a problem because they read some article and thought something was cool and wanted to just try to invent something in some area. And then there was also situations where they wanted to do something that would be like a PhD thesis worth of work, and they thought they were going to do that in like 6 or 7 weeks. And so some of the projects that are struggling a bit now are ones that are, I think, too big and would need to be, like 2 semesters of work. So to conclude, and this is, once again, this is a QR code that has all the slides here, including after my main slides here, you'll see 5 slides per student project that pitch their project and have information about that if you wanted to get more information about them. But the main things that I've sort of observed from this is identifying problems themselves is actually quite a difficult thing for people to do who are new to the space. And for many of us, it maybe seems quite easy because we see problems everywhere, but for outsiders, they're sort of not aware of what's possible to solve, what's already solved by 18 different companies, you just have to pay for it, or what exists. They also don't know what they don't know. That's yet another problem where there's a lot of, you try to climb some mountain that people have been trying to climb for 50 years and no one succeeded. That's going to be really difficult. From what I saw from the students, they often didn't want to inherit a large code base, but they really didn't mind working on someone else's idea. And this surprised me a little bit, that they were pretty eager to take ideas from the community. So if you do reach out to master students or others like that who are looking for things, you might really be able to drag people into this cool idea you have and get them to work on it. And also, they're often hesitant to reach out. There's a lot of imposter syndrome, and these communities can feel a little intimidating. And I think that's true, by the way, for everybody. Like, I've had imposter syndrome at times, and I can't imagine how hard it is for other people who don't always look exactly like, I think I look pretty much like the typical tech person, but for people who don't look that way, I imagine it's even harder to deal with issues like that. So really, these students need guidance and support to become part of the community. And I thank you in advance for those of you who've already helped to make that possible, and welcome anybody else doing that in the future. So thank you all very much.